This is your teacher, Daddy Cause, and in this video we'll be talking about corrosion of metals. We're talking about corrosion of metals because air that we are dealing with presently is responsible for making metals corrode, and alongside with water, metals do corrode. So we define corrosion as an environmental problem that arises when water and oxygen react with metals. And metals corrode faster due to the presence of carbon dioxide or sulfur dioxide in the air. Electrolytes generally accelerates the corrosion of metals. One of the most important metals that corrode is iron. Corrosion in iron is always referred to as rusting. So iron rusts when it combines with oxygen and moisture to form hydrated iron 3 oxide. You call hydrated iron 3 oxide rusts. That is the name you give to hydrated iron 3 oxide, rust. And the formula is Fe2O3.X of water. Now, when this compound is formed on the surface of iron, this brown substance called rust, whenever it's formed on the surface of iron, the substance becomes flaky and not sticky. It doesn't stick to the surface. If it sticks to the surface, it will have been another advantage. But the substance is flaky and breaks off easily from the surface of the metal. So once it forms, it gets broken off, then exposing the internal atom to corrosion. Those ones also will become rusty, break off, exposing other metal. So because of that, iron can corrode completely if left to the to that condition of oxygen and water for a long time. All the iron can completely corrode because the rust that is formed on it does not stick to it. It breaks off, exposing the internal metal and the internal atoms to further corrosion, to further rusting. So how can we prevent iron from rusting? In fact, a branch of chemistry is dedicated to prevention of rusting because it is very, very economically advantageous when you prevent metals from corroding. Most of the structures that we have are made with irons. Look at the vehicles, look at buildings, look at structures, engines, machineries. Many of them contain iron, which is susceptible to rusting. And when iron rusts, it brings a lot of damages. Imagine when the bridge becomes rusted, vehicles can pass on it and the bridge will break and people will die. The exhaust engine of vehicles, the exhaust pipe, when it becomes rusted, it can lead to a lot of bad effects on the vehicle. When the tank of the vehicle becomes rusted, vehicle starts leaking, and when it starts leaking, the vehicle can explode when there's enough heat. So preventing iron from getting rusted is actually a very important aspect of the economy of a nation. And that's why a lot of methods have been developed to prevent iron from getting rusted. And all these methods are based on one principle: either preventing the iron from reacting with water, or preventing the iron from reacting with oxygen, or both of them at the same time. So once you can prevent iron from reacting with water or oxygen or both, the iron will be preserved and will not rust. So one of the methods is electroplating. In electroplating, you are coating iron with another metal electrically, you call that electroplating. For example, you can coat iron with copper, or coat iron with silver, or coat iron with gold. All those metals that are not easily can be corroded easily. So those ones that cannot easily be corroded easily, you can use them to cover iron, and when you do that, the iron becomes protected. If you use electrical method to do that, you call that electroplating. That's coating of a metal by a thin layer of another metal to prevent the metal from getting corroded. That is electroplating. Another method of preventing rusting is by galvanizing. Now, galvanization is a method of coating a metal with zinc. In this case, we are talking about iron. Coating iron with zinc is called galvanizing. You are not using electrical method here. You are putting the iron into a molten zinc. You melt the zinc. As you can see in the picture, the zinc is in the liquid state. Then you dip the metal inside the liquid zinc and remove it. As you remove it, the zinc will solidify and cover the metal. You call that galvanizing. When you coat a metal with zinc, you call that a galvanized metal. That's another method of preventing corrosion. The third one is by painting. When you see most of our structures being painted, especially the metal structure being painted, what comes to our mind is that we are trying to beautify the metal. Good, fine, that's one of the purpose of painting. But the major reason you paint iron is to prevent the iron from getting corroded. Or why do you want to paint a pipe, for example? It's why do you want to beautify a pipe? So most of the reasons you paint metal structures is to ensure that the metal structure do not get corroded or get rusted easily. That is painting. Another method of preventing corrosion is by enameling. Enameling has to do with coating a metal with enamel. Most of the times, it is pots and cooking materials that we coat with enamel. You coat the inside and outside with enamel. This material was normally used by our parents in the olden days. When they want to present their visitors with, food, they use enameled plates that have been covered with enamel. Enamel, though, beautifies the plate, but most importantly, prevent oxygen and water from reacting with the iron plate so that it doesn't corrode at the end of the day. Another method of preventing rusting of iron is by oiling the iron. When you oil the iron or you grease the iron, water cannot mix with oil. So once you have covered the iron with oil, water will not be able to interact with the iron. So anything you can do to prevent the metal from having contact with air, or having contact with water, or having contact with both of them, that method will prevent the metal from getting corroded. And as you can see from the picture that we have here, once you oil the moving part of the engine, apart from the fact that it will lubricate the moving part and avoid friction, it will also ensure that the engine will not get corroded, because oil will not allow air and oxygen, air and water from acting on the iron. Another method of preventing rusting is by alloying the metal. That is, you mix the metal with another metal. How do you alloy? You melt the metal, you melt the second metal, and you mix them together in that liquid state. Then allow them to solidify together. You call that alloying. Alloy is a mixture of two or more metals. So, and most of the iron that we use in making buildings are actually alloys in form of steel, chromium steel, like the one like the one that is used in electroplating, stainless steel, the one that is used as a surgical instrument, used in our kitchen, stainless steel. They're actually alloys of iron, and hardly will you see a stainless steel getting corroded or getting rusted, because alloying itself is a method of actually preventing corrosion of metals. Then finally, that I'll be talking about on how to prevent corrosion from taking place is by sacrificial protection. Sacrificial protection. What do you mean by sacrificial protection? When you protect a metal by using another metal, actually it differs from coating and electroplating in the sense that the metal that you are using is a more reactive metal than iron. So if I want to protect iron, for example, I will attach blocks of maybe magnesium or sodium. You know, in our electrochemical series, your sodium, potassium, your potassium, sodium, magnesium, calcium, aluminum, zinc, like the other series. You can use a metal that is more reactive to protect another metal that is less reactive, so that when you expose them to a corrosion environment, it is the more reactive metal that will start corroding, leaving the less reactive ones. So if I want to protect iron, for example, I can attach blocks of magnesium. You know, magnesium is more reactive than iron. So I can attach blocks of magnesium or attach blocks of maybe zinc on it instead of coating all the iron with zinc. You know, there are some cases that it will be difficult to paint the metal. For example, a pipe that runs from here to Kaduna, that runs from Lagos to Kaduna rather, will be so long that to paint it will be very cost intensive. So to prevent this, you can cut zinc metal and attach it to the iron at regular interval. Maybe every 1 kilometer, you are attaching zinc metal to the iron. Now, what this will do is that it will make the iron not to corrode, because you have already attached another metal that is more reactive than iron. So as long as the zinc metal still remain on the iron pipe will not corrode. Instead, it is the zinc metal that will start corroding. You call that sacrificial protection. We are sacrificing the zinc to protect the iron. So that zinc becomes a sacrificial metal or a sacrificial anode in chemistry. When we deal with electrolysis, you know the meaning of anode and cathode. So whereas the iron is the one that you are protecting. So when you use a more reactive metal to protect a less reactive one, you call that sacrificial protection. Just like a parent will put umbrella on their baby during rain and themselves will get drenched. That is sacrificial protection. You are protecting the baby, whereas using the umbrella that you could have used to protect yourself. So because you are stronger than the baby, you allow rain to fall on you while you protect the baby. That's sacrificial metal. In case you are walking inside rain, you have your certificate in your hand and your chemistry textbook in your hand. What would you prefer to do? You prefer to use the chemistry textbook to cover the certificate, so that at the end of the day, even if the chemistry textbook is wet, you still have your certificate intact. So in that case, you are protecting your certificate by sacrificing your chemistry textbook. That is called sacrificial protection. It's normally used when you have a long metal to protect, or a large volume of metal to protect, and galvanizing or coating or painting is not cost effective in that particular situation, then you just sacrificially protect it. Like it's normally used inside ship. The hull of the ship, that is the fan of the ship, is normally protected with zinc. You can also protect a long iron pipe with blocks of magnesium metals at regular interval. That's sacrificial protection, using a more reactive metal to protect a less reactive one. All right. So, what is the meaning of combustion? We have discussed flame in our previous video, and flame is always produced during combustion. It's an exothermic reaction between a fuel and oxygen. Most of the time, flame will not be formed if there's no oxygen. Only very few situations can a substance burn without oxygen, except, for example, when hydrogen burn inside chlorine to give you hydrogen chloride gas. That's another form of combustion that does not use oxygen. But most times, whenever a substance is burning, it burns in the presence of oxygen. So we define combustion as an exothermic reaction between a fuel and an oxidant with the production of heat and light. So whenever heat and light is formed, that's a flame already. So during combustion, flame always happens, and that is why combustion is a little bit similar to roasting. Number one, both roasting and combustion requires oxygen. Don't forget, combustion can also be burning the same way. It's the same thing. Roasting and combustion, they both require oxygen. That is, they are both oxidation processes. Number two, they both give out heat. Roasting produces heat. Combustion produces heat. So they are both exothermic reactions because they both produce heat. Now let us see differences. We have seen similarities before. Differences between roasting and combustion. Number one, for roasting, water is necessary. For combustion, water is not necessary. In fact, combustion is very difficult when there is water. Number two, roasting always involves iron because only iron can rust. Other metals will corrode, but iron will rust. Iron will turn to rust. Iron 3 oxide, hydrated iron 3 oxide. But other metals cannot form rust. But combustion does not need to involve iron. Anything can burn. Paper can burn. Plastic can burn. Other things can burn, not necessarily iron. Number three, roasting is a slow process. Roasting takes place over a long period of time, but combustion occurs rapidly. It's an active, rapid process. In roasting, small amount of heat is generated over a long period of time. But in combustion, large amount of heat is generated within a short period of time. Then for roasting, finally, the heat produced during roasting is not perceptible. You don't usually feel it. You don't usually you cannot perceive it. But in combustion, heat given out is perceptible. You can easily perceive it that this is producing heat. So that is difference between roasting and combustion. God bless you.